Now with this result we have something else also. What we have next is, what is this entropy? Now I say entropy is equivalent to some energy because we are talking about the change in entropies, that means change in all combined form of energies which constitute the disorder in a system. So it is some energy only, it has the units of energies, but we say that this energy is useless. Why? Why is it useless? Because this form of energy which is resulting in disorder is basically wasting of energy. This energy cannot be retrieved back, right? Because we are not doing this with providing any input. This is a spontaneous process and it is, leaving its ordered state to go into disorder state. So this kind of energy is like me wasting my own energy which I cannot retrieve back. Earlier what we did was we provided some energy which did some work, and if we retrieved it back by doing the work, the same work in reverse direction, we could actually get that energy back. But in this case, this is the useless energy, right? For instance, or for example, or for the analogy, you can say the food I am eating, it provides me with energy, right? Now with that energy I have two options. One, I do some productive work, or I am doing just lazing around and just sitting around or just wasting my energy in blabbering or some rubbish stuff. That kind of energy is actually I am wasting that food energy. So similarly, whenever we are talking about entropy, entropy means the system is going towards the disordered state and it is wasting its energy which cannot be retrieved back, because when we need or when we require that state, disordered state, to come back to its original ordered state, we again have to provide energy. You can see that we are spending energy in both the cases. First, the system is spending its energy in going towards the disordered state, and then we are providing the external forces and external energies to bring it back. So this is basically the useless energy. So when we come back to this statement that the entropy of the universe at any instant of time is increasing, अब ये मेरा universe है, इसकी suppose initial entropy is S naught, right? And it has some energies in it, I say E naught. Now what happened is, including, I'll write this as universe, right? So what is happening is, this universe has some E naught energy, which is the total sum of the energies present in this universe at present, and S naught is its present entropy. Say after t seconds, what will be the entropy change? Delta S will be positive. So that means ST will be greater than S naught. Entropy is increasing. Suppose now this delta S is basically at the cost of this energy, because out of this energy only spontaneous processes are occurring and increasing the entropy. So I'll write that E naught ET, the leftover energy of the universe after t seconds, will be E naught minus delta S. You can see this is a decrease in energy because delta S is positive. That means ET is less than E naught. It means that E naught was the energy which was of my use, but out of that E naught, delta S amount of energy is now being converted to this useless energy which I cannot use. It has just vanished, right? So we always say spontaneous processes resulting in increase in entropies of the universe are always going towards a disordered state, making or converting the useful energy of the universe to the useless energy which we cannot retrieve back or use back. This is a major statement, right? So this was all about the entropy कि what is the entropy, उसका क्या concept है, वो क्या कर रहा है, क्या वो impact डाल रहा है हमारे universe के ऊपर, right? So this was all about the theoretical part. Now when I said there is no concept of absolute entropy and we are always talking about the change in entropies, some of you might be thinking who have studied the statistical mechanics, there we come to know or there we come across a statement which says entropy is K ln W, where S denotes my absolute entropy of that state, K is my Boltzmann constants, and W is the coefficient of disorder. This is the case which is in statistical mechanics. In thermodynamics, there is no concept of absolute entropy, but in case of the statistical mechanics, we come across this equation which says absolute entropy is K ln W. Just to clear this confusion, I would like to tell you is this entropy is not the same as the entropies we are talking about in thermodynamics. In thermodynamics, entropy is some kind of energy, but in statistical mechanics, entropy denoted by S is calculated on the basis of probability. Probability of occurrence of this state which has coefficient of disorder as W. This is different. This entropy is telling me the probability of a state which has the coefficient of disorder W. That means there is a restriction that I would like to know that what is the probability of a system to be present in a state which has 10 molecules not in its place, or say 20 molecules. This is that thing. This is not the random thing. What is the degree of randomness? It is not degree of randomness. It is the probability of that state of occurrence. So don't confuse this with that. This is altogether a different theory, which we'll be covering in, of course, the statistical part when we'll be doing that subject. For the time being, absolute entropy has no significance in my thermodynamics. It is some kind of energy, and we'll always talk about the change in entropies. I hope it is clear to you.